Professor Bob Young here, and we are going to talk about in this instructional video absolute value inequalities. Now, we have already talked about absolute value equations on the previous video here, so let's just review a few properties of absolute value. So we notice when b is greater than 0, now this just means that the number is going to be positive here. The absolute value of a equals b if and only if a equals b or a equals the opposite of b. So for example, we've already did examples where the absolute value of 7 is 7, the absolute value of -7 is 7, because the absolute value is the distance a number is from 0. So when you say the absolute value of x is 7, there are two numbers 7 units from 0 on the number line. So usually two answers to absolute values. And we also did the double absolute value. Now what we haven't done is what's called the inequalities here. So we're going to look at properties 3 and 4 in this video. Now notice if the absolute value of some number, or whatever's in the absolute value, is less than b, then to solve for this, let's think about this for a second. Let's say the absolute value of x is less than 7. Think of numbers that work in this problem, like for x, 6, 5, 4, 3, 2, 1, 0, -1, -2. But when you get to -8 on x, it's false, because the absolute value will always spit out something that's either 0 or positive. See, so what it is, so if the absolute value of x is less than 7, then by this third rule, x must be between -7 and 7 in order to satisfy the inequality. Let's think about rule number 4 here. What if it's a greater than, Young? What if you've got some absolute value x greater than some number 7? Then think about what numbers work in this one. Well, x would have to be a number greater than 7, 8, 9, 10, 11, a million, so forth. Or, if you think about the other side, x would have to be less than its opposite, or -7. So -8 would work in for x on example 4 here, or property 4. So be careful. So I like to say that if it's less than, you've got the tweeners, and if it's greater than, you've got the breaststroke. For you swimmers out there, if you've got the absolute values greater than some number, then it's to the outside, or think of a breaststroke. If you know how that stroke goes, it's to the outside of the number and its opposite. So let's look at some examples here with those two. So, and one other thing I've got to type in here, this is huge here when you're solving absolute values. And we talked about this in equations already, but make sure you always, let me go ahead and capitalize here, always isolate the absolute value first. Always isolate. So I put AV. You know what AV stands for? Yeah, absolute value. All right. So notice here they gave us, this one's by itself, but we may get to some tricky ones down the line here. The square root of 2x plus 1 is less than 7. So we're just taking whatever's in here. And again, like in my last video, don't mess with whatever's in here. I don't care if it's got positives in there, negatives in there. If it's inside that absolute value, do not mess with any signs or anything else in here. Just take what it is, put it between the number and its opposite, and solve. And you will get x's between -4 and +3. Now remember, you have to write this in interval notation. So numbers between -4 and 3 is written in interval notation, -4, 3. Why parentheses? Because it does not have the equal to in the inequality. Let's try one that's greater, very similar. So if it's the absolute value of 2x plus 1 is greater than 7, we're going to use property 4 there. We're going to take what's in this absolute value, say it's got to be to the left of -7 or to the right of 7. So this is what I call the breaststroke here. Solving, you'll get your two answers. So these are very nice too. I like the absolute values. Those are kind of nice here. So you'll get numbers to the left of -4 or to the right of 3 will satisfy this inequality. And here is how you write that in interval notation from smallest to largest, left to right order. Now, just to show you that these numbers will check, let's take a number to the left of -4 on the number line. Let's check something here, because students go, you never can check these, Young. I'm going to let x be guess what number? -5. Young, you're so creative. All right, so I'm going to plug -5 in here for x, and what do we get? The absolute value of 2 times -5 is -10 plus 1 is greater than 7, which now becomes -10 plus 1. The absolute value of -9 is greater than 7. Well, what is the absolute value of -9? +9. It does indeed check and make sense. So if you're not sure about, inside or outside the numbers on these, just make sure when you're done, plug them in and make sure it makes sense to you. All right, now here's another example. Solve the absolute value of 2 minus 7x minus 1 is greater than 4. And here's one where the absolute value is not isolated. Oh, you don't know how many times I see students make this mistake. It's almost like when you solve the radical equations. You always have to isolate the absolute or the radical first. You always have to isolate the absolute value first as well. And notice, since this is a greater than statement, we're going to use property 4 again, and we're not going to mess with what's in here. We're going to say whatever's in there is to the left of -5, or whatever's in there is to the right of -5. So notice, do not mess with this. Signs or nothing. Solve and get your answers. And notice when you solve this one, it's the old, you have to divide by a negative. Flip it. Flip it good. Dun, 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 dun. Bum, bum. And if you do it there, you got to flip over here. Now, if you don't flip when you need to flip, whenever you multiply or divide inequalities by a negative, flip. And there is your solution set, both an inequality and an interval notation. So good stuff here. All right, now there are a few special cases we're going to talk about to finish this video. Now, if you ever get an absolute value here, now in all the other examples and on absolute values, equations, or inequalities, we've always talked about this number out here being positive for the most part. What if it's negative? What if you have the absolute value of something greater than or equal to a negative? Now, notice the solution here says since the absolute value of a number is always non-negative, so in other words, no matter what I put in for x here, this is always going to spit me out something that is greater than or equal to 0. Would you all agree? Which is always going to be greater than or equal to some negative number. So in this case, the solution set would be all real numbers. And notice here, if you get a less than, if you have an absolute value less than some negative, again, no matter what I put in for x here, it's always going to spit me out something greater than or equal to 0 here. So it's either going to be positive or 0, so this will always lead to a false statement. So if you think about it, the answer here is no solution. And the other special case is if it's equal to 0, you notice I've been saying most of the time the absolute value will have 2 solutions or 2 parts. When you have an absolute value equal to 0, it's the only time you'll ever get 1 part, if you think about it. And we talked about that in the previous video. So just watch out for these special case ones. If they ever slip you a negative in there with an absolute value, this one would be the set of real numbers. You would put x equals all real numbers in interval notation. So you can write it this way or this way, but that's always going to be true, no matter what you put in for x. If it's less than, it's never going to be true, because that absolute value always comes out something positive. All right, Bob Young signing off. That is absolute value inequality.